Hello everyone, welcome to the solution of LeetCode problem 417 named Pacific Atlantic Water Flow. In this problem, there is a n by n rectangular island that borders both the Pacific Ocean and the Atlantic Ocean. The Pacific Ocean touches the island's left and top edge, and the Atlantic Ocean touches the island right and bottom edge. Now, the island is partitioned into a grid of square cells. You are given a two-dimensional integer matrix heights where each of the element represents the height above sea level of the cell at coordinate R and C. Now, the island receives a lot of rain and the rainwater can flow to the neighboring cells directly north, south, and east and west direction. If the neighboring cell's height is less than or equal to the current cell's height. Now, water can flow from any cells or any adjacent cell to an ocean into the ocean. Now, we have to return the two-dimensional list of the grid coordinates results, which denotes that the rain can flow from the cell RC to both of the Pacific and Atlantic Ocean. That means we have to return the list of the coordinates of the cell where the water can reach both of the Pacific and Atlantic Ocean. Now, I hope you understood the problem statement. I will explain the example in the next algorithm section. Now here, to understand the algorithm, we have taken this example mentioned in the example 1. Now, let's see how basically the water flow begins. Let's see, it is the height. Suppose the height is 4. It is also the height is 4 and it has the height of 3. Now, if the water flow from the top, this water can flow to its right direction, and from this it can go its right direction and go into the ocean. So this is how basically the flow begins. But the question is, how can we solve this problem? Before jumping into the solution, let's see in this two-dimensional matrix which cells water can flow both of the Atlantic and Pacific Ocean. Suppose for this cell 4, if the water falls into this cell, it can go to the right because the neighbor has 4, which is equal to the 4, or it can go up. The neighbor is 3, it can go to the 3. Now from 3, it can go to the Pacific Ocean, and from 4, it can go to the Atlantic Ocean. So we can see that the cell 4 can have the water which can reach both of the Atlantic and Pacific Ocean. Similarly, for this cell 5, the water can directly go to the Pacific and the water can directly go to the Atlantic. Similarly, for this cell 5, the water can go to the Atlantic and the water can go to the Pacific. Similarly, for this 7, the water can go to the Atlantic and the water can go to the Pacific as well. And for this 5, the water can also reach 2 of the oceans. This is the intuition and the explanation of the algorithm. But the question is, how can I solve this problem? We can basically solve this problem by using the DFS in a two-dimensional grid method. Now, how the DFS basically works here, the intuition is very simple. At first, let's take this row. Now here, from this row, we will call the DFS function and we will think in a reverse order. How? Suppose for this cell 4, its water reach the Pacific if the value 3 is less than or equal to 4. Now, as we will start the DFS into the border cell, we will think that suppose currently we are at this cell 3, it can reach the water from its neighbor if its neighbor has the height greater than or equal to 3. This is how basically we're gonna solve this problem. We will run a DFS from each of the border cell. Now, we will check whether our current cell's water can reach the Atlantic Ocean and can reach the Pacific Ocean or not. If our current cell's water can reach both of the Atlantic and Pacific Ocean, we will simply store it into the result array. Now here, we will take two of the two-dimensional array, which will store in which cell can reach Pacific and can reach the Atlantic Ocean. So here, suppose this cell can reach the Pacific Ocean and this cell can reach the Atlantic Ocean. Now, as both of them are situated into the same coordinate, we will check simply that yes, if we consider this coordinate, we can reach both of the Pacific and Atlantic Ocean, and we will simply store it into a result. This is the basic intuition of the DFS. I hope you understand it. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named Pacific Atlantic, which has a two-dimensional array height. Now we are calculating the dimension of the height. And we are taking two Boolean array, Pacific and Atlantic, to store whether I can visit it from the boundary cell or not. Now, we are calling the DFS for the first column and the last column, and we are calling the DFS from the first row and the last row with the Pacific and Atlantic vector. Now, inside the DFS, we have to mark visited true. Now here, if the value of I is greater than 0 and the value of or the cell of I-1j is not visited and the height of I-1j is greater than or equal to height of ij, that means here we can consider it and we have to recursively call the DFS function with the I-1 and j. And this is one direction. Similarly, we have to check the condition for the rest of the three direction as well. After that, we have initialized the Pacific and Atlantic Boolean array. Now, if for each of the cell, the Pacific and Atlantic contains the truth value, that means that we can reach these cells to the both of the Pacific and Atlantic Ocean. So that's why we have to store the coordinate of it into a vector and finally return the result. I hope you understood the algorithm. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.